Alamak, aku tertutup. Shit. Aduh, salah. Tak banyak pun.
In this video, I'm going to discuss binary to decimal conversion. But before I do this, I want to take a look at positional notation, or place values. I have the number 2,168 here. If we look at the place values of the number 2,168, we can see that the place values have the ones place, the tens place, the hundreds place, the thousands place, 10,000, 100,000, and million. These are the place values of the base 10 decimal number system. You can see that we have the number 2 in the 1,000s place, so we have 2 1,000s. We have a 1 in the hundreds place for 100. We have 6 in the tens place for 60. And we have 8 in the ones place for 8. So effectively, we have 2 1,000s, 1 100, 6 tens for 60, and 8 ones for 8. Now, when we're talking about the place values in the decimal number system, we're talking about the powers of 10. You can see that the ones place is the 10 to the 0, the tens place 10 to the 1, the hundreds place 10 to the 2, or 10 times 10, which is 100. The thousands place is the 10 to the 3, or 10 times 10 times 10, and so on and so forth. So you can see that the place values are based on powers of 10. If we look at the number 2,168 then, in long form, we can see that effectively we have 2 1,000s, 1 100, 6 tens, and 8 ones, and 2,000 plus 100 plus 60 plus 8 totals 2,168. This is the type of counting and addition that we learn as children. The decimal system is base 10. It's based on the fact that you have powers of 10, but more importantly, you have 10 characters or 10 numerals in this counting system, from 0 all the way up to 9. So that means that in each place value, you can have anywhere from the number 0 up to the number 9. In other words, if I had the number 9,168, I'd simply replace the 2 here with a 9, and now I have 9 1,000s totaling 9,000 in the 1,000s place. So in any one of these place values, you can have the number 0 all the way up to 9. This is the base 10 decimal number system. If we consider binary and look at it in the same light as decimal, binary is a base 2 number system. There's only 2 characters, or 2 numbers, 0 and 1. So under the place values, we can only have 0s or 1s. The place values go...
Yep.
طب القلوب ودوائها وعافية الأبدان
Using what?
وشفائها
Tak ada apa je.
Baru first time nak buat dia punya.
Hush.
Allahumma salli ala Muhammad. طب القلوب ودوائها.
What? Who use it? Who use it, goddammit? Who use it?
وعافية الأبدان وشفائها
Sama kat tong. Wah, tu dah 3.
ونور الأبصار وضيائها
Tak lah, self eject.
اللهم صل
Buat sekejap. Ya, Assalamualaikum warahmatullahi wabarakatuh. Kita akan mulakan proses head hunting.
Go from 1, which is 2 to the 0, to 2, 2 to the 1, 4, 2 to the 2, 8, 2 to the 3, or 2 times,
Ada beza
and the
dengan
ones
apa yang
place,
belajar.
32 bit. The next octet is all zeros with
Tak ada beza sama je. Dia convert the positional rotation. Okay, rotation. Learning to convert binary to decimal requires understanding of position notation. Position notation means that a digit represent different values depending on the position. The digit occupies a sequence number. You already know the Pascal binary system, best notation system. Ini basically terang pada apa yang dalam video. Ni aku dah malas ni. Aduh. Jom kita ke stand-nya. Okay, tengok what base main for. Kita nak dalam 192. Tak payah. Dia base 32 nombor kan. Total 32. Ni dah semua 8. 8 nombor. So 8 ni dapat apa dalam binary? Ni. Sampai ni. Beza dia kat sini tau. Semua sama. Okay, kita tengok 162 pula. Tak ada dalam decimal unit. 168 168 lah. Ni betul. Ni betul. Ni betul. Salah. Okay, kita tengok 11 binary. Dua ni betul. Malas aku nak cakap sama je semua. Show me lah. Check. Betul. Sama je cara kira je. Kira pun pakai kalkulator je. Dan kalau dia minta kira, pakai dalam sini manual. Masih 8 sebab apa dia ada kosong 1, 2, 3, 4, 5. Macam 2, 0, 0, 2, 0, 2, 2, 0, 3, 2, 0, 4, 2, 0, 9 sampai 2, 0, 0, 2, 0, 8 2, 0, 0, 1, 2, 0, 2, 3 sampai 2, 0, 7. Setelah dia repeat tapi sampai 2, 0, 7. Faham tak? Nampak? Sama je. Aduh. Decimal to binary conversion. Benda siap. Okay lah, tengok. It is decimal number of itu kan tak start okay. Aduh. It is the decimal number of octet and equal to greater the most significant 186. If no, then enter binary kosong. If yes, then add. If n less than equal to 181 and 168, bigger than. Why? Why? I don't know. Why? Untuk ada bahasa lain lah. Binary to decimal conversion to help understand the process, to consider the IP and the first octet or the octet. So cara kira apa ni? Tak payahlah, tahu dah. Tak, dah simple je ni. Habiskan je lah. Holy shit, I can't see the difference.
Now you know how to convert binary to decimal and decimal to binary. You need that skill to understand IPv4 addressing in your network. But you are just as likely to be using IPv6 addresses in your network. To understand IPv6 addresses, you must be able to convert hexadecimal to decimal and vice versa. Just as decimal is a base 10 number system, hexadecimal is a base 16 system. The base 16 number system uses the digits 0 to 9 and the letters A to F. The figure shows the equivalent decimal and hexadecimal values for binary 0000 to 1111. This graphic has 3 columns. The first column has the numbers 0 through 15 in decimal. The second column has the numbers 0 through 15 in binary. All of the numbers in binary are expressed with 4 place values. For example, 0 is 0000, 10 is 1010, 15 is 1111, etc. The third column is parallel with the other 2 columns. This column has the numbers
the heck?
0 through 15 in hexadecimal. These are expressed with one value. For example, 5 is 5, 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. It should be noted that these may be
Okay.
expressed with upper or lower case. In this diagram they are all uppercase letters representing the numeric values.
Alright. When what? Aku copy lain, macam mana boleh baca lain? What? Huh? Mau lain ini. Now you know. What the heck? See? As if. Entah. Aku pun tak tahu. Tak apalah. Psst. Psst. F. Ada 4 S digit. See? Aku faham. Ni ada. Mm.
Hexadecimal, or the decimal equivalent, or dividing by 16 isn't always easy when doing hex to decimal conversion. 69, so I'll place a and then I'll rewrite the +1 first example. And that gives me 1 plus 16.
This doesn't answer my question. See? Macam ni aku answer ni 32. Valid hexadecimal F. What's this? Check it out. Betul tak? Betul. Shocking. Katakan saja ku terima. C has a value. Tengok Tengok daripada hexagon. Silap. C9 dalam decimal 201. Itu je lah. Itulah jawapan dia. Tak ada apa. Thank you. Sama panjang mana? Macam mana? Macam mana? Macam mana? Okay, thank you, thank you, thank you. Thank you dah. Thank you sebab tengok. Satu minit pun dah 2 minit, patut 2 jam. Terima kasih. Assalamualaikum.